Hey, I'm Simba Khadder. I'm the founder and CEO of Featureform, and I like to drink my coffee Arabic style.
And we're back with another MLOps community podcast. I'm your host, as always, Dimitrios, talking to my man Simba today. And we got into the traditional and the new AE. Simba gave me a great breakdown on embeddings because he was one of the first people that I heard use the term embeddings back in like 2020. He told me why he was so intimate with that term because of his recommender system work that he did back in the day and why that spurred him to go and create a feature store of his own and start selling it. And so now he is doing the thing that one tends to do when you create something cool or when you have a pain and then you figure out how to ease that pain. You go and bring it to the market to see if anybody else has the same pain. He really walked through different ways of looking at feature stores. I appreciated that, how vector stores and feature stores can play together and why they're so oftenly confused between needing and if you need one, do you not need the other? If you need both, how does that look? And then we talked about LLM land and how personalization is a must when it comes to LLMs. I usually look at it as variables. He gave me a little bit of the light bulb going off in my head and told me, it's just features that you're talking about. Variables are features. And so we can bring those into LLM prompts just as much as we can bring other things into LLM prompts, like the context that you get from a vector store. Enough from me. Let's hear it from Simba. Dude, so you were the first person, and I gotta give you credit for this because before LLMs, you told me, I'm pretty sure everything's just like moving. It's all going to be embeddings. And I remember thinking, I barely know what an embedding is. And that's how I know it was before LLMs. Because once LLMs came out, I think everybody understood what embeddings were. And can you explain that position? Has it changed since then?
Yeah, you also have to, it's an experience to have people come to you and try to explain to you what an embedding is. Like I'll be talking about something, and we're like, oh, there's this thing called embeddings. I'm like, oh, tell me more. I've never heard of them before. So yeah, that's like a day in the life. Yeah, I think it's still true. I mean, part of how I got into embeddings, and like, I guess into embeddings, part of how I began to kind of get interested in that field and kind of like I would say at the time, more the cutting edge of deep learning was I was doing recommender systems. And what was really kind of new then, and maybe now kind of, actually, I'm still seeing some articles about it, like the two-tower architecture, where you're seeing people kind of pushing holistic understanding of items and users to the model itself, and essentially turning users and items into embeddings. So this concept of like, hey, we have this holistic view of what something is. The analogies around, like in text, we often hear about like the king is to queen as like man is to woman. You can get way more sophisticated than that. I remember I did embedding generation for an e-commerce data set. And one really cool one I came up, one really cool like kind of analogy, which looks like a parallelogram and embedding visualizer was Coke is to Diet Coke as Cherry Coke is to Coke Zero.
Really? Wait, how does that work out?
Well, like, I think when I think of the flavor profiles, like Coke is a generic, like that's the standard, Diet Coke is the sugar-free. Cherry Coke is like Coke standard, but there's almost like a slightly different, like vanilla, extra sugary flavor to it. And Coke Zero is like Diet Coke, but has, again, that same kind of extra flavor profile. And I can kind of explain it and we could talk about it and be like, yeah, that's how it tastes. But the crazy thing is that this model was able to derive that just by looking at, user X bought item Y. And the first time I started seeing stuff like that, I just was like, man, like it really deeply understands what these things are all by itself by looking at really sparse data, which if you take that and maybe expand it, you kind of start to see what LLMs are. Or if you take that to an extreme level, you're like, hey, if you just read random text, one token after the other, like a model can actually start to understand ideas and concepts and things that you wouldn't really think would be possible just by reading word to word. So this is a very long answer to your very short question, but I think the real answer is that yes, we're always sort of at the beginning of things. I think there's always these S curves of like there's a new architecture that comes out or a new style or new, in this case, like a training technique, and that just pushes us to the next level and then tends to plateau for a little while, and then it goes to the next thing. At the same time, though, every single time that happens, everyone's like, all right, everything we've ever done is now deprecated. And I remember when, deep learning became a thing and everyone was talking about it, even like 2017, 2018, it's like, yeah, everything else is, deprecated now. Like we don't need anything now. Everything is going to be deep learning and that's it. Like feature engineering is dead. Everything else is dead. We just have to deep learning. But to this day, probably the most common model in production is some form of a random forest, like XGBoost or something similar. And I wouldn't be surprised if that still remains to be true years into the future.
Yeah, and there's the stories that come up consistently of folks that go through university, they do a bunch of cool deep learning problems, and then they get on the job and they're like, where's all my deep learning? What is going on here? First of all, you don't have the data for deep learning. Second of all, that's not what we do here. And so get used to XGBoost, baby.
It's so true. And yeah, there's a big gap between how people learn about machine learning and what it actually looks like in an actual company.
So I really like the idea that you mentioned before of this two tower architecture. I think that's cool. And I hadn't heard that before. And basically you're saying, if I'm understanding it correctly, the customer is put as one type of embedding, and then the item or whatever people buy is another type of embedding. And depending on how close these embeddings live to each other, you can recommend certain embeddings.
Correct. Yeah, actually how we would do it is we would, if I want to recommend something to a user, there's another common strategy, which again has become popularized, which was called re-ranking, where we would use an embedding and we would do candidate generation. So I would take, let's say I'm YouTube, and YouTube actually popularized this in their paper, where they were like, hey, I have a user embedding. I'm going to take this user embedding that the model figured out all by itself, just based on behavioral kind of items. And I will figure out 1,000 or 10,000 video embeddings that are near this user embedding. And those are my candidates. And then I'll have specialized model, like one for the side view, one for the autoplay, one for whatever, where I will re-rank those 10,000 candidates to decide what to show people. And so the one thing I think is that, yeah, embeddings it's not just like a text thing. Like we can do embeddings on a lot of things like users and items, images. And then the other thing, which I think a lot of people miss, and this again, getting popularized. I feel like everyone's relearning a lot of things that people in recommender systems learned a few years ago now. But the other thing is that you can actually use embeddings as a drop-in, as a feature in a traditional model. So for example, if you have a ranking model and you want to put an item as like an input, you can actually just put the whole item embedding in and do that. You can do things like average embeddings together. Like I can take the last 10 items the user watched and I can just average them together and blend it, and that actually works. But the other funny thing about embeddings is it works except when it doesn't. And when it doesn't, it's a quite painful experience of trying to figure out what's happening, because you kind of have
debuggability,
abstractions on abstractions. Yeah. It's which is why like XGBoost and things remain very popular, because they might not always have the best performance, but they always do quite well, or they almost always do quite well. And you can kind of start to understand what it's doing and why, so you can figure out, make it not do dumb things as easily as.
That's such a great point. It reminds me of a video I watched on how windmills that are your typical windmills that we've probably all seen, especially in wind farms, those tend to break like 10 times more than windmills that spin on the y-axis as opposed to the typical ones. And so the windmills that spin on the y-axis and are just spinning around in circles like this, and for anybody that's just listening, you can think like a water bottle that has holes in it and it's just spinning on the y-axis. Those break. The ones that are the typical ones, those break a lot more than the ones that spin on their y-axis. And so you have to do some calculations on, all right, I can generate more power with the typical windmills, but it's in spurts because it's going to eventually throw me an error and it's going to break. But I can get like 10 years of no breakage with these very simple windmills. However, it's not going to generate as much power. So it's almost like the tortoise and the hare. And that reminded me of it because you were saying, hey, you can have this very powerful architecture of setting up with embeddings on embeddings type thing and using those as features. But when it breaks, you potentially are going to spend a lot of time trying to debug it and figure out where it's breaking, as opposed to, hey, let's try this simple architecture that if it breaks, we don't need to spend that much time debugging it, and it is not really going to break as much, or if it does break, we can get the uptime is much higher, right?
Yeah, I think that's spot on. It's just more accurate in its simplicity. Like it's what it's going to do, and depending on, you just have to think of your problem space. Like in some problem spaces, maybe having that really that amazing once in a while model recommendation prediction is worth the bad predictions. And there are other times where, hey, I'd rather have it do pretty good, every time than have it do amazing, most of the time, but really badly some of the time.
Well, I feel like you wanted to go down this route, but I know there's people that ask the question frequently, how do vector stores and feature stores play together?
Yeah, it's a good question, but it's almost a funny question because if they didn't both have this word store in them, I don't think anyone would ask this question.
But they both kind of play with embeddings, right? You were saying the feature stores have the embeddings, and then vector stores for sure are all about embedding.
Yeah. And they both kind of touch data. I think it's true. I think it's more like it's not things that I typically put right next to each other. But yeah, I remember like in the early days we released embedding support in Featureform, and there was a mix. It was mostly people asking like, or being like, okay, like we don't understand. Very few people at that point were like understanding what that meant and why. We like open source something called Embedding Hub, which is like a really early vector database. And I think the key difference is really the value prop. So I'll tell you what the key difference is today and where I think it's going. So the key difference today is that a vector store is a specialized index, which makes it really quick to do nearest neighbor lookups. So to do true nearest neighbor lookups where I give you a point and you find me 10 points nearby is a very, very expensive problem. And so there are many algorithms that give you approximate nearest neighbor lookups. And that's a vector database. And so they typically build indices. A really common one is called HMSW, which Facebook released. In the early days, there was a library I used to use a lot called Annoy, which was Spotify,
right? Yeah,
mm-hmm. Spotify did it. Actually, that's Eric's the guy who built Annoy, or I believe he built it by himself. But whatever, him he's released it, or I associate with him. He's now the CEO of Modal. So it's funny how all these kind of things, even though people work on very different things, everyone's kind of seen and played with a lot of the same tools. But yeah, so the problem with a lot of these indices is they don't actually really fit well into the traditional database models. The only one that kind of does is a specific one, which is, I believe it's IVF. It's not as good as HNSW, but it's a little easier to scale, and it works better and looks more like a traditional index. But anyway, so a vector database is a way to index your vectors through embeddings such that you can do nearest neighbor lookups pretty quickly. And there is a give and take of how, of recall, and that's kind of the difference between the different algorithms. There's also a difference in speed and latency, scale, usability, UX, whatever. So that's where the vector databases kind of fight amongst themselves. Feature stores are almost solving quite a different problem, but has a little bit of overlap. The problem that feature stores are solving is the problem of a lot of ML is inherently a specialized form of data engineering. Like you take data and you turn it into features, put in a less ML wordy way, like I have raw data and I need to pull signals out of it. And so a lot of what I'm doing is just kind of iterating on the data to get the best signals that I can provide to my model for it to do a good job. Now, there's a lot of problems that come into that. Some of it is organization, like versioning, lineage, governance comes up a lot. And there's a production problems, which is, okay, well, even if I build this thing in my notebook and I use polars or pandas, well, I need to get this in prod. And in prod, if it's like a recommender system, it can go down or bad things happen. So how do I build a enterprise grade data pipeline for all these features I built? And by the way, like I'm a data scientist, like I'm not a data engineer. And so what we see a lot of is like data scientists going to data eng teams and giving them notebooks like, oh, here's my notebook. Can you please put this in prod? And so there's this like awkward friction between data eng and data science, where data engineers are like these data scientists have thousands and thousands of things they're throwing our way, and we just have enough stuff to do. And in practice, like the amount of asks that you'll get from data science versus the ROI of every specific data pipeline is actually, the math doesn't really math very well. And then for the data scientists...
Wait, because of the data scientists being way more valuable, like the stuff that they're asking to put in production is so valuable? Is that why
actually it's more that like, hey, this might incrementally increase my model a little bit.
Oh, okay.
And
so it's a lot of asks for a little bit of lift.
Correct. It's the data scientist's job, and that little lift does make like a difference to the business, but from the data engineer's perspective, it's just like painful. And from the data scientist's perspective, it's like, how can they do their job? Like it's science. It's a lot of hypothesis testing and throwing stuff away and evaluating things. If every experiment is very expensive, then you can't really do your job very well. And so where we find feature stores being really valuable is making it possible for data scientists to kind of self-serve, build and experiment and deploy their own feature pipelines, and have us be kind of like this harness that gives them, the versioning, the monitoring, the scale, the uptime, all the things that you would expect, incremental processing, stream processing, everything you would expect, and maybe a really good data engineer could do. We make it possible for our data scientists to do themselves. And so the problem space is different. Now, the overlap is that, well, sometimes those features are embeddings. And so that's where the overlap is.
I see. That's where they dance together. Because I think the confusion comes in when you hear folks talking about how they're using vector stores for their recommender systems.
Yeah. And I think what it is I would describe it as everyone has a feature store. If you have a model in production that takes data as inputs, whatever process you take to get that data there and manage that data processing, that's your feature store. Now, that could be a bunch of bash scripts. It could be a Python package that you install in the Docker container and just like do the processing on the fly. Like, there's a lot of things that people do, but that whole kind of promise space I would define as a feature store. And a lot of what I'm doing when I'm talking to prospects is trying to understand if they have models of production. It's like, you have something here. Help me understand like what that looks like today so I can show you what the kind of ROI would be.
Yeah. Do you feel like there are phases to when you need more of a bulletproof solution as opposed to those bash scripts? And because I remember we had Neil Lethia on here ages ago, and he was head of ML at Monzo Bank. And one thing that he said, I think they had their own homegrown feature store, right? And he was saying, yeah, what I see with, if we wanted to buy something off of the shelf, that's us going and trying to leapfrog in a way. It's us saying, cool, we have nothing. Now we're going to one really quick because we can buy it off the shelf, as opposed to we've already got something in there and it's working, and the gradual increase of us making it better and better. And so I wonder if there's patterns that you've seen where you're like, I recognize that you're currently at this scale and you want to go and do it this way, or I recognize that your current architecture or the way that you've set it up is this brittle, because I can only imagine that we all, in the back of our heads, we know our weak spots, and we are all just expecting, even if it isn't, we all kind of have nightmares of how brittle our systems are. And so anyway, tangent aside, if there was a question in there, I'm sure you're going to answer it right now.
Yeah, I think the question, I would define it as like, when do you actually need a feature store, or how do you even decide, like, feature store aside, like how do you do that analysis of like, okay, it's time to go with a vendor or something off the shelf versus, hey, we have our own homegrown hacky thing. We know it's hacky, but what's actual ROI of going for something else? And I actually think that this question was at the heart of, we both kind of saw like an implosion of MLOps startups, because there was this like humongous, like everyone had an MLOps company for like a moment in time a few years ago, and then a lot of those companies don't exist anymore. And there was this kind of era where people were buying MLOps just almost experimentally, like, let's just try this, or we heard this is a good idea, not really thinking of ROI, just more like we need more shiny tools. And I actually think that LLMOps kind of sort of looks like this today.
That's what I was going to say. I don't know if I fully agree with a lot of those companies are not around anymore. I think a lot have maybe pivoted to LLMOps companies, or the story has changed because folks feel there's a bigger market out there with the LLM use cases, which I'm not necessarily sold on, but that's a whole nother conversation. So forgive me for interrupting you.
No, I think I think the companies that maybe we're referencing are companies that I would say were like above the fold. So companies that most people knew about and had some, there's just like this whole, like for every monitoring company you knew about, there was like 15 that, very few of us had ever heard of. Same with feature stores. For every feature store company you've heard of, for every Featureform, there's 15 companies that even I didn't know about a lot of the time until I'd randomly run into them in like a cycle, or someone's like, oh, there's this thing that has no website that we're thinking of using. And so, yeah,
My
I
brother
think there was
John
that era.
has a friend who says he knows a thing or two about feature stores, but also, I'll let you make your point on the question that I didn't ask before, that I tried to ask but couldn't get out. But I will say that feature stores feel like it is relatively strong, because you do see that folks are still coming out with new feature stores. Like there's, I heard about Chalk the other day, and I heard about, what's the one that Airbnb open sourced, right? And so the fact that there are more people coming into the space, even though it is not viewed as like the booming space that it once was, is still a good signal. And I know that you mentioned before we hit record that like, it's just something you do. It's not as sexy as it was in 2020, but it is still something that is very useful.
Yeah, I think if you talk to, at least in feature store space, I don't know so much about the other MLOps spaces, but at least in our space, even like our competitors will say like, yeah, like all boats are kind of rising in feature stores. There's just way more. I think what it was a lot of people didn't really fully understand the problem space, or they kind of understood, but like, we need to do this ourselves and field ourselves. That might have been driven by a little bit of like, I think good reasons in some places. We're like, hey, before we bring this vendor in, let's make sure we actually understand this problem. There's probably some bad reasons where, hey, this is like the hottest thing ever, and everyone who's doing this is writing blog posts, so I want to do this and not buy it, which, always happens in new categories. And I think we've moved past the era where it's like, hey, the ROI of a feature store is kind of well understood now. If we, have data scientists doing ML and they're working with data, if they're always complaining about all sorts of things related to the data, feature store is kind of an umbrella that solves a good set of those problems. But just get one. Like, there's enough of them. They're well proven at this point. They have big customers. Like, are we really going to build this in-house? Why? And I think the other thing we ran into is, even though a lot of companies could build in-house, like you mentioned, like Airbnb, like what ends up happening in a lot of those companies is if they build something valuable in-house, the team that builds it then leaves, starts a company, and kind of leaves the company holding a bag of like, oh yeah, this thing that we built originally that now everyone who actually wanted to drive it forward has now left, and all you're left with is like maintenance on it, and it just degrades, which we've seen a lot of.
That happened with the LinkedIn feature store Feather, I think, which is a bummer because when it came out, we interviewed the folks that worked on it, and then it feels like it didn't get picked up and it didn't get the energy that it needed to be injected into it. But you made a great point on resume-driven development. And in 2020, there was so many blog posts about feature stores. That's so true that, yeah, if I'm going to be working in the MLOps space, what am I going to do? Well, an easy win is I build my own feature store. And we even had Nicholas on here a few weeks ago, and he was talking about how he has BigQuery as their feature store-esque type solution. And so it is like that thing still happens. And that was the reason that I wanted to ask you the original question that I asked you and didn't let you finish and give your answer to. So now I'm going to shut up. I swear I'll go on mute and I'll let you give your answer.
Yeah, I also have the problem of like, I'm like, oh, we can talk about all these other things too. But yeah, coming back to the main problem that mentioned, which is, hey, I have BigQuery. We have this kind of ad hoc process in the house, and we use it as our feature store. Do we need an actual external feature store? So first, I'll answer it very pragmatically of like, you own the whole MLOps platform, and a feature store is just one of many things that you can invest in buy. I think in practice, there are 4, call it modalities, that like a ML engineer or data scientist will be in. There's the data modality, which is like when they're working with data and putting data pipelines in production. There's the training modality, which is like experimenting, sometimes locally, sometimes in notebooks, just like building models. This is where like MLflow, like this is the part of the model pipeline we're using something like MLflow or weights and biases or something. There's model production, which is okay, now I have it's in a model store. I actually need to get it in production. I need to serve it. It needs to have this uptime, this latency, all that sort of stuff, GPUs, all that comes in. So there's deployment, and then there is evaluation and monitoring, which is the final bit. So those are kind of the 4 modalities and arguably the 4 problem spaces. So to say them in order: data, model training, model production, or model serving rather, and then monitoring and evaluation. So my first question would be, okay, talk to your user, because you're a platform team. So if you think of your platform like a product, your goal is to make your ad user happy, and your ad user is a data scientist or ML engineer or something. So what do they, of those 4 things, what's causing them pain, and does that pain equal, like beyond just like, I hate this? Like, is it slowing things down? Is it causing errors in production? What else? Typically, the answer is almost always going to be one of monitoring, evaluation, or data. At least in practice, I've seen that those two tend to be the ones that have the most pain. And it's no surprise then that when you think of like MLOps startups, the ones that have kind of most done, I think, have done quite well are companies in both of those categories, data being feature store companies and then monitoring evaluation companies. Interestingly, in LLMs, you could almost ask the same questions and you end up at the same place where most of the problems are data and monitoring and evaluation. But I could come back to that later. But yeah, so that's the first bit, is like, which one matters? If it is data, the question becomes, well, what about the data? And one thing about like Featureform specifically, and part of how we built it and why we built it, we call ourselves a virtual feature store with the premise that it sits above your existing infrastructure. So the problems that we solve are much more about productionizing things and operationalizing feature pipelines. So it sits above BigQuery, it sits above the vector store, it sits above these things. So it's an application layer that sits above your infra, and it makes it all work together coherently like a feature store. Gartner came out and called this concept a logical feature store. We weren't, even though I came up with the name logical feature store, it felt kind of like a underhanded thing to say we're the logical feature store, so it went virtual. But conceptually, it's like the logical layer, the semantic layer of features above the infra. And so if you have a data problem, the question then becomes what kind of feature store? And there's three kinds, which I can get into. But maybe I'll take a second and let you ask any follow-ups you have.
Don't even get me started on Gartner. That's all I got to say about this.
Yeah, but it's an interesting business model of Gartner's.
Well, so the fascinating bit is the four pieces of the lifecycle. And I do like how you've clumped together. Like, there's the data piece, which is there's so much inside of that data piece that can be a headache, right? Like just the data acquisition, or as you were talking about earlier, you mentioned a few good things like the governance or transformation or access even can be a pain depending on if you're at a gigantic company or not. And then you have the deployment. The model training is another interesting one because that one for sure feels like there's less pain there because the tools, in my eyes, are very mature. And so you look at like a weights and biases or an ML flow, and those tools feel very mature compared to the rest of this life cycle. And maybe that's because the training has been around almost longer than, that was like the first thing to kind of pop up in the life cycle. I don't know. Maybe you have theories around why those tools are more mature.
Yeah, they just came a little earlier. And I think the problem space is a little more well understood. I think data, like you said, like what does that even mean, is very dependent on the type of company. So the solution is has to be way more complex. And same with monitoring and evaluation. Whereas like training and serving, it's like an end. It's like this, lots of matrix multiplications and GPUs is yeah.
Yeah, just throw more GPUs at it. You're all good. And so, okay, there we are. Now, keep cooking because I know you wanted to say something else.
Yeah, I want to maybe dive, because the other thing that I think there's a lot of confusion about with feature stores is, okay, like I get it, like there's this data problem, but there's all these feature stores and they all look kind of different, but they all call themselves feature stores. So kind of like understanding what's actually happening there and what you need. And one thing we've done is we've kind of broken up the feature stores into three distinct categories. And the categories are interesting because they all kind of came about at the same time, and they were just three different solutions to the problem. One solution, which was popularized by Feast, I would call the literal feature store, where you literally just store your features there. This is kind of how Databricks' feature store, SageMaker's feature store looks, where you transform it and you build it somewhere else, and they would define the feature as like a table. So the artifact of the transformation is the feature. So the benefits, it's really simple. Like you just have a new sink to put your, features into. The cons is everything I just said about productionizing feature pipelines, dealing with streaming data, versioning, lineage, none of that stuff really gets solved by the literal feature store. So in some ways, it's like a very simple add-on, but in other ways, it doesn't really do much. With the Databricks' feature store, it's almost like such a lightweight thing that it's almost like a specialized sub part of the Unity catalog. So every single table in Databricks' Unity catalog that has a primary key, they just put in the feature store. It's just like, it's the same thing. Like a table of a primary key is a feature. Like that's kind of their approach. And then, part of the other problem they solve, I should make sure is clear, is that there's another big problem with features, which is training and inference. At training time, you need kind of batch high throughput data of all my historical feature values. And then in inference time, I need to be able to just do a quick lookup. Like, hey, Demetrius, just open up Spotify. I need to do recommendations for him. I need to look up the features now. And so having like these pre-computed cache features and stuff, like Redis or Dynamo, and keeping that in sync with your training data is another problem that these things solve.
Yeah. Wait, can we pause real fast right there? Because there's something fascinating for me when it comes to Databricks and SageMaker feature stores and these end-to-end platforms like Vertex or Azure, I think, has one too, right? And it feels like what they did is almost like what Microsoft Teams did against Slack, where Microsoft just said, you know what, you get Office? Cool. You can also have Teams. And so SageMaker said, yeah, cool. You have SageMaker? Well, you also get a feature store. And I would love to hear your thoughts on how that is. Like, when you look at the space and you see big platforms that just kind of throw in the feature store as a part of it, where's your head at on that?
Yeah. I'll answer this in two parts. First, I'll answer from the perspective of Databricks.
Yeah.
So Databricks or something like Databricks. I'm just going to use Databricks just because it's they have a feature store, but that's well known. So Databricks, their NRR, which for those who don't know, is kind of like their net revenue retention, which is like if I have, X customers and they pay me $1 billion a year, ignoring new customers, how much will those customers, the same ones, pay me next year? And so it's almost like upsell, like how much more are you paying Databricks or
Land
AWS?
and expand. Yeah,
exactly. And so I believe their number, and someone's going to probably fact check on me, but I'm going to say their number sort of kind of looks like 150%. Even if it's 120%, let's just say 120. If they're at like $1 billion revenue, that means that those customers paying $1 billion revenue now pay them $1.2 billion next year if they do nothing. Like they can literally do nothing and they just make 20% more dollars than they made the year before. And they are held to task on that. It's a huge revenue. It's a huge metric that like companies like Snowflake and others are held to. And so how do you do that? Well, there's one bit, which is, okay, like just make people use the product more. And there's another bit, which is like, okay, well, like how do we make it more, how do we get it in more places, make it more sticky? So they're like, oh, ML, big use case, lots of money there. Like, let's just throw tools at it that make it useful for ML and make it stickier for ML, and we benefit from there. So that's kind of the perspective, is just like, we need to get people to spend more money on Databricks. So they're already on Databricks. It's easy to get people to spend more money on a vendor they already have and to get a new vendor in.
Yeah.
And so we'll just do that. So then there's a question of, okay, feature stores. Databricks has one. And I think this is where like the space, and I think a lot of spaces have to justify the incremental value. And so Featureform, we took the approach of being open source. We also took the approach of playing very nicely with Databricks' feature store, for example. In fact, every feature, if you're using Featureform in Databricks, every feature that's built with Featureform runs on Databricks and appears in the Databricks feature store. So it's like Databricks is feature store plus plus, like it's only incremental value on top. And then the question becomes, okay, well, like how much is that incremental value worth to you? And, if it is valuable, we charge X dollars, how much ROI do you get on that? And so there's some math to be done there. But yeah, I think you're right in that a lot of companies are releasing these and taking this platform approach. There's kind of this idea of like data gravity, where if data all lives in one place, it's easier to kind of sell like more things on top of it. And I think the question really becomes quality, which is like the AWS. Like AWS has a service for everything, right? But it's kind of accepted that the AWS one is kind of the baseline. Like it's like, okay, like it can only get better from here, but is this good enough? And I think the same is true of Databricks. But Databricks, I think, to their credit, still has more of a quality component than maybe like AWS's service do. Mm-hmm. So there's maybe more of an argument to be made. And anyway, I think it's a very long answer to what I think of like the there's a business reason why they do it. And that business reason, it's not like we're trying to be an MLOps company. I don't think I won't say they don't care about the quality of it, but it's more of a way to drive more spend of Databricks. So anything they can do, they could just kind of add on. Is just a way to drive more Databricks spend. And in a funny way, if we continue to do as we're doing, continue to do well, continue growing, and we become like a de facto feature store, I don't think Databricks cares. I think they're like, cool, we'll just support Featureform because they're still driving more Databricks spend. And in the end, that's all Databricks cares about.
Yeah, if you look at what they did with Mosaic, that's exactly to what you're talking about. They bought Mosaic and they said, now you have a place inside of Databricks to do all your LLM stuff.
Yeah, and Tabular was an interesting acquisition where they were just like, cool, we're just gonna, that one has a very fun story behind it, but the very short of the story is like we can pretty much make a whole differentiation not be differentiation anymore by just unifying every data format or table format under one. And so, yeah, they've done very well. So not a company that's easy to compete against, as Snowflake, I think, and others are saying.
Yeah. So I derailed you when you were talking about the different types of feature stores. That was one type, which is, you called it the literal feature store, right? Classic feature store like Feast, or I'm pretty sure that's what we had Nicholas on here using BigQuery as that. That's where they stored features. And so...
And that's why the name gets, and that's what a lot of people think a feature store is, which is unfortunate because it's like, oh yeah, it's a feature store. It's a place where you store features. And this is where like the vector store comparison comes in. It's like you store your features in the feature store and the vectors in the vector store. But how about if my vectors are features? Where do they go? And that's where people get confused. But I would almost argue that a feature store isn't really a feature store. It's not really a storage of features. It's just a term that got coined and all of us are kind of stuck using. Other companies like Tecton, for example, they've gone and tried to rebrand the term. We call ourselves a virtual feature store. They call themselves a feature platform, which all are just trying to show, hey, it's not just a storage of features. And so that gets to like my next maybe category, which I call the physical feature store. Some would call like a feature platform. And this is where like Tecton lives and others live. And the approach there is that you do the compute. So it's not just, it's the features defined as a pipeline, which I think is the correct definition. If I think of a feature in my head, the top 5 things the user clicked on, like when I think of that, I'm thinking of it as like almost like a SQL query in my head. It's not the table at the end. It's the actual definition. And so the physical feature stores approach is like, hey, data scientists can give us these definitions. We will build them and make them production ready for you so that you can very easily iterate on features, use them in prod, get that monitoring, get the versioning, get all that, those nice things that you need. And we have this hyper-tuned compute framework that we think is even better than Spark. You mentioned Chalk. That's kind of they mentioned their thing of like, are you tired of Spark? Like you use Chalk. And so that's their approach. It's like, okay, we are owning the feature pipeline and we are building those features better than you can yourself and better than Spark can.
So, excuse me, this is what Nicholas was doing with BigQuery. They were computing, and now that you say that, I'm remembering the conversation because he was saying, before we implemented BigQuery as like the standardized spot, we had all these ad hoc jobs running because data scientists would introduce a little bit of feature compute into their code, and then when they would run it, it would run here or there or whatever. But once we introduced BigQuery in, we had it standardized, like day and night, we would compute all of them and you would get the most recent version, right?
Yeah, and this is like super, yes, and that's like the value, and that would be, I would call kind of like in that feature platform place. Now, if a company in the feature platform, physical feature store space was to go and sell to this person, they would say, yeah, we do it even better than BigQuery. So we will process those features. We'll read from BigQuery like a source, and then we will compute them and then put them, and essentially we will handle the data from there. The benefit is it truly might be faster, cheaper, whatever. The con is typically adoption cost. All of the physical feature stores are proprietary. There's typically, because they're proprietary, you can't really tune them in the same way you could tune something like BigQuery or Spark. There's no such thing as like an expert at tuning those things. It just doesn't exist yet. So the con typically comes with partly data gravity. It's like, I'm already in BigQuery. Like, I already have BigQuery, I already have Databricks. Like, why am I going to buy another compute player just for my ML team? And so that's kind of where our approach, which we call it the virtual approach, it's like virtualizing a layer on top. So pretty much what would happen if you built that feature platform, but rather than actually building the compute engine, we just build plugins to BigQuery, Spark, Snowflake, all these different tools. And we tune those tools as well as we can to do the feature compute. So from the data scientist's perspective, all they're doing is giving us like their data frame transformation or SQL transformation, whatever. We will then handle productionizing that feature on their existing data infra. And so, yeah, the benefit we see is just adoption cost is way lower for companies. Like what most companies build in-house kind of looks like an ad hoc version of Featureform, because almost no one is going to build a compute platform in-house. Like, and no one's going to be like, we're going to build a better BigQuery. I mean, that's what Airbnb and Uber did back in the day. But I just don't think that the math makes sense anymore, especially given that other things exist out there. So really, they end up building on top of BigQuery or Spark or whatever. But that's what Featureform is. And Featureform's open core. So like, if you're going to do that and you don't want to pay, like, you can still just use Featureform to do that for you.
So explain a little bit more about this idea of connecting things and how then you're using these engines, whatever the compute engines are, and then you're spitting out the features to the virtual feature store, and then it lives there. And how is that different? I'm trying to see how that's different than what you were saying in the beginning, the literal feature store of like, okay, it just lives here and these are the features.
Yeah. So 2 points. One is you're not ever really spitting it out to the virtual feature store. It is the whole thing. It maybe put one way, it's like the literal feature store is like cache, like a database for features.
Yeah.
The physical feature store is like a compute and storage framework or engine for features. So it's doing the compute, it's doing the storage. The virtual feature store is kind of more like an orchestrator and metadata. So whereas like in the physical feature store, you would compute in their compute engine and then you store in their storage engine, or maybe they support Dynamo or Redis, but generically their compute, their storage. We do the same thing, except you plug in the compute like BigQuery and you plug in the storage like Redis, and then we will make all those things kind of work together. ClickHouse has written quite a few articles about us and about using Featureform and ClickHouse, because from their perspective, similar to Databricks, they want to have more use cases of ClickHouse, and ML is a big one for that. And so a feature store just makes it easier to use ClickHouse for ML, so that data scientists don't have to learn the ins and outs of using ClickHouse and optimizing ClickHouse pipelines. They can use Featureform, which already has all that built in. And so now a data scientist has to think about, hey, I have this transformation. I'm going to write it. I'm going to register with Featureform. Featureform will then build it and put in prod for me, keep it up to date, do stream processing, incremental processing, do point time correctness, all the things you'd expect to be done. Featureform does, similar to what a feature platform does. but it's being done on your data infra.
I see. I understand now. You're the connector where there's already whatever, a Spark cluster, or you guys do Hadoop also?
We don't. We do have, it's been asked for. We've had some interesting, because we work with a lot of bigger companies and enterprises, we've had some interesting asks.
Well, it's funny, just a random side note on the Hadoop thing. Someone came into the community the other day and they were saying, like, I've had it with Hadoop. The Hadoop community is a graveyard. If you want to make any changes, your PRs don't get merged until 3 months later, maybe. And so we're watching Hadoop just slowly crumble before our eyes right now, which is an interesting thing as technology is constantly updating. You can see that. But tangent aside, I get it. So you've got the connectors. Nothing new needs to be brought in as far as the storage or compute side of things. It's just that you're able to optimize whatever is already in production or whatever is already on your stack. So you're optimizing it by saying, hey, data scientists, like, you don't need to learn ClickHouse. You can just do what you're best at and let us work on that optimization of ClickHouse.
Yes, I think that's true. Maybe to make it like a little more clear, let's say you as a data scientist are working on like a streaming pipeline. Like, so you have like a stream of user buys and you need to build a feature there. In the literal feature store, it would be your job to go to DataEng to build that pipeline in Flink or in Spark Streaming or whatever. And then you'd have to build a production grade DataEng pipeline and manage it and maintain it and have monitoring and have all the things you would need yourself. That's the literal feature store. In the physical feature store, in the kind of feature platform approach, you would be able to do it yourself. And it would work and be great, and it would handle streaming quite well, and it would scale well, and it would be production grade. But it would have to run on their compute. So you have to bring a new compute engine in, a new storage engine, it's proprietary engine. In Featureform, you still just write your SQL query like you would. Featureform will then take that SQL query, and it knows it has like a harness to get that SQL query in and run it in a way that is a production grade data pipeline. So it's really clear when you start thinking of things like incremental processing and streaming, on top of having versioning, lineage, search, reuse, all the other stuff you'd expect as well.
Okay. Now, you did mention before there's this LLM aspect to things, and you were saying it's, when it comes to the data lifecycle, it's also very similar. Although LLMs are this new thing, you still almost have like the same data lifecycle and you still have the same pains. And I think that's why we're seeing 1 million evaluation companies come out. So I agree with you there. Can you go a little bit deeper on to what you've been seeing and how you've been thinking about that?
Yeah, I think there's a lot there. I'm going to actually just fully focus on this RAG, the concept of RAG, and the data part of LLMs. So RAG, when we first kind of came out as a concept, was this idea of I take my documents, I chunk them somehow, I embed them, I do a nearest neighbor lookup based on the embedding of the user's prompt or query, and I have some prompt template that I feed my retrieval. So if I do a nearest neighbor lookup, I get 5 paragraphs from all of my documents that most look like the question, and then I'll just feed that into my template. And it works pretty well. Like it does. It's just like naive RAG implementation. And a lot of people did that and they were like, this is it. This is cutting edge. I think we're going to look back at this and be like, it's so funny that we thought that this was like the end all be all. This is what RAG is. I think RAG at its core is the problem of I have a context window. It's either a set size, like n size, or the bigger I make the context window, the more expensive the query is, and just I don't want to just put fluff in the context window. So my goal is to have the most information-dense context window possible, which is really an information retrieval problem. Like, how do I retrieve context, the best information that I can feed into my context window? And where a lot of people think of like text and there's neighbors and etc. Imagine if I asked you, hey, Demetrius, how should I invest my money? I want to save up for retirement. You would probably ask about my age, my income, my risk profile. You ask a lot of questions about me and about how my situation. Those answers are not in a vector database. Like, you're not going to get someone's age. You're not going to do a vector database lookup to get their age. Those might exist in like a Postgres database somewhere. But if you're giving that context to a prompt, like, it would make sense to say, hey, I have someone who is, 30 years old. They have this much money. They do this, that, this. But no one thinks of it that way. Like, everyone thinks that you have to do nearest neighbor lookups and embeddings and vector DBs. And I don't think there's any reason that that is true, other than one, it does work quite well, naively. And two, it just, those companies came about first, and almost all the content about RAG is written by those companies or proponents of those companies. So and this isn't even like a hit on vector DBs. I think vector DBs are extremely powerful, like I said earlier. I just think it's part of the puzzle, and really the problem space is, and I think honestly where a lot of vector databases are going to go is become less a vector database and more like a context retrieval database, where I give it a prompt and maybe some other metadata, and it has all of these signals that maybe like exist in a feature store or something, and it decides what to pull from the feature store and feed into the prompt. That's kind of the architecture that I think things are going to move to. We're already seeing a little bit of that happening.
Oh, I love it. Yeah. So basically, right now, that personalization aspect in the prompts, you don't see as much. I've seen people talk about, you have variables, and you want to have variables that you can use across prompts. And so you store those variables in some kind of a database, and then you can reference them in different prompts. That's been really cool to see. I have heard of the idea of, let's personalize prompts a little bit more. I feel like instinctively this works for certain use cases, but not for others. But then, as I was trying to think about what use cases it wouldn't work for, I couldn't think of any off the top of my head. So I was like, well, maybe that's not true. I'm just making that shit up in my head. So I don't know. Do you have any insight on if it's more relative for certain use cases versus others?
I think it probably is. I think what you'll find, the most valuable use cases for LLMs, because LLMs are relatively slow, they're kind of expensive. You're not going to use LLMs for fraud detection. Most of where you see LLMs being used and where the value is coming from is making, like, co-pilots, like making people better at their job, making them move faster. So they're interacting with a human, almost always. And I think that's actually where LLMs do best. Their augmentation tool. I'm personally a little skeptical of what can be done in the automation space, true automation where no one touches it, because I don't think you can achieve that 99% accuracy you need. I mean, you get to like 95, which sounds great until you realize that, hey, if it's fraud, like that 5% of fraud that's getting through is not just like, we can't just look over that.
Accounts. Yeah, that's not super fun to think about.
So I think that everything in some way has this level, and it's not just personalization for the user, but I do think that's a big piece of it. Even just like what you're calling variables, those are just features or signals or whatever. Like, we give these things different names, but really all it is I have these conceptual things and I want to pull numerical or textual data points about them so I can feed that into the model so the model can do a better job. At its core, that is a feature.
Yes, you're opening my mind now, because I was thinking of it just as attributes of a human, but it's exactly that. Like, the variables I know are describing a company, and then in your prompt you just put the company name in quotations and it can grab that, but that is exactly what it is. It's a feature. Yeah, so you have all these different variables that you want to be able to give the most context and the most accurate context to the prompt so that the LLM can do the best job that is possible. And so it makes sense that you would break it down and really get as descriptive as possible for all these important themes, not just like, hey, this is company A. It's like, if you have a very rich description of what company A is, you add that as the variable.
Yes, and you're seeing like graph rag and knowledge graphs kind of get pushed too, which is a very similar pitch of what I'm saying. And the really funny thing is like then you have graph rag and they're like, you need that and not vector databases. Like there's this weird like either or philosophy, even rag versus fine tuning versus like awkward. It's like everyone's just trying to justify that they are the best way to do them because there's no real good data yet. Like no one knows. I think there's very few enterprise grade LLM products in the world. I think the only one that you can really look at as like gold standard is GitHub Copilot. I think everything else is still kind of in like very valuable, but maybe more either consumer driven, which like consumers can handle a little more. It's like can be a little weird sometimes, or just very experimental. Like in B2B, you see a lot of things that are going out that don't actually work very well. They have great demos, but they're not quite there yet. And I think where we'll get to that next level is when we get to the point where it's just like, hey, here's your data. I have a very specialized retrieval, these very specialized prompts. Maybe those are models themselves, which I've actually seen people starting to use traditional ML models for re-ranking, which is fascinating. And
Wait,
then the
explain that a little more? I didn't catch that. Sounds cool.
So if I have 1 million signals that are relevant to the prompt, the question then becomes, which ones do I feed into the prompt for this specific query? And how do I properly place them in the prompt so that the model can understand it? And that question and how to do that, I think that is where every like a Llama Index-esque type company, I think that's where everyone kind of starts. That's where the big, hard, open question is. I think the vector databases will start to compete there. I think a lot of the companies will start to compete in that space. And I really think that's probably one of the hardest problems to solve. And if you can solve it well, it just becomes a no-brainer to use. But I actually, similarly to feature stores, I don't think there's really a perfect way to solve it. So you either get very specialized, verticalized ones, or you will get or you will get more generic ones that give you ways to tune them and specify what you want to do where. But really, that's the problem to solve with LLMs. And I think a lot of people get too caught up in like, I need a vector database and I need to do nearest neighbor lookup, and they forget the core problem, which is just information like packing. Like, how do I pack the right info and the right density of information to achieve the best result?
I think that's why for a lot of people, DSPy felt so interesting, because it has that capability of like fanning out and testing a lot of different prompts and then saying, well, here's the winner of this choice, right? And so you could see that being something that becomes more attractive, and you start to see incorporated into a lot of these frameworks.
Yeah, I think that's true. I think evaluation, I don't go too deep into it, but I find evaluation to be really interesting and kind of funny, similar to how recommender system evaluation used to be, because the hard part of recommendations is most people don't give it a thumbs up or thumbs down when you give them a recommendation. Very rarely happens. And on top of that, there's almost like a certain profile of person who does that, and that's probably not the average person. So if you take both those things into account, the question becomes, well, how do I decide if this was a good recommendation? And the answer is implicit info. Which is like what Google does. Like, okay, Google, if you search something, did you click? How long did you stay on that page? Did you go back and click on another page? Like, you can kind of deduce if a user had value. And I think evaluation is so focused on like, we're going to do this statistically or mathematically, or even funnier. It's just like, we're just going to layer LLMs on top of LLMs until you're so confused about what's happening that you can't understand it. And will you ever say this is good or bad? When really the answer is, all that matters is the end user. And like we talked about, most of the time the end user is literally a human. So did they find value in it? If yes, then that's good data. And if no, then no. And this is actually what OpenAI, like ChatGPT does, right? Like sometimes they'll give you the two prompts next to each other. Like for sure, they're using that information to like decide and tune their models. So I think that's what you're gonna always see these new user experiences that are driven to teach the model more, which again, we saw in recommendations. And I think that we're going to see the same thing in LLM. So I think it's so interesting coming from Rexes to LLMs and also having seen a lot of things in between, because I just am seeing the same pattern play out.
History rhymes.
For sure.